So in this video, I'll try to do a problem from Virginia 2012. So what we have here is an integral of cosines and sines, and what I will do throughout my videos, I'll try to write x instead of cosine x and y instead of sine x to just save myself some time. And just note that this x has nothing to do with this x in the cosine. This is just, I'm using this as a symbol. I could have just used some other variable, but I'm used to x and y, so I'm just using them. Okay, so when we rewrite the whole thing, when we write the integrand in terms of x's and y's, we get this thing, and we'll try to simplify it as much as we can. So when we look at the numerator, we have an x. Everything is an x. So we could probably factor that out, but I'm just gonna group them first, because it seems like we can factor with an x squared from here, x cubed, and y squared and x from here, and then both of them will have the same thing, so you can factor it that way. So we have x cubed, and then x plus y plus y plus y squared x, and then y plus x, sorry, x plus y, that's okay. So this y is coming from there, and this x is coming from this other side. Okay, and then I guess these factor to x plus y. Then we can pull out the x from there, so x, and then x squared plus y squared. But x is cosine x and y is sine x, and cosine squared x plus sine squared x is just 1, so this cancels out. So we have x times x plus y. And then the denominator, what I will do is I'll try to group the ones that have more y's together and the one that have more x's together. So in this case we'll have y to the fourth 2y cubed x, and one term from here in one group, and the other one would be the ones I didn't underline. So this is half underlined. Yes. Okay. So when we do that, what we get is, I guess we could factor out a y squared from the ones I'm underlining. Y squared, from here I'll be left with y squared, and from this other side I'll be left with plus 2xy, plus on this side I'm just taking one of the terms, meaning I'm taking y squared, x squared, so I'll be left with just x squared. And then when I do the ones I didn't underline, I'll factor out an x squared again, and then I'll be left with x squared plus 2yx plus y squared, and then these two are the same, so that means I can factor these terms. And if you have noticed, this can also it can factor out. So what we have is y squared plus x squared times this factors to x plus y squared, and then like we said, y squared plus x squared is just 1, so we have x plus y squared, and this is the denominator and this is the numerator, so this cancels one of the terms there. So what we have is x over x plus y, and when we rewrite this in terms of cosines and sines, we get cosine x over cosine x plus sine x, and this is, if cosine x is not 0, then this is just 1 over 1 plus tan of x. So everything simplifies from 0 to pi over 2 f 1 over 1 plus tan of x. So in our limits, x is just from 0 to pi over 2, like when we do the Riemann integral. So this is defined. There's no point where x would be pi by 2. So we don't have to worry about dividing by 0. And this is dx. Okay, now we'll do substitution. So if we let u be tan of x, du is just secant squared of x dx. And then when we plug everything back, oh yeah, and then the limits change. So if we plug in 0 for x, we get 0. And then if we plug in, I guess, pi over 2, it's not really going to be pi over 2, but it's shooting to infinity. So our limits change from 0 to infinity. And then we have 1 over u plus 1. And then the secant squared, because secant squared is just 1 plus tan squared, we have to multiply this by 1 plus u squared, and then du. Okay, and then now we can do partial fractions to rewrite this. So this would become, let's see, so we'd have a over u plus 1 plus bx plus c over 1 plus u squared. And then this becomes a 1 plus u squared plus bx plus c u plus 1, and this whole thing equals 1. If I plug in minus 1 for u, this goes away, and then this becomes 2, so a is 1/2. And then we have, when we look at the terms for u squared, we have a plus, let's see, sorry, this should be a u. Okay, and then we have b equals to 0, so b is minus 1/2, and then c, I guess the constant term is just c. Sorry, the constant term is a plus c on the left side, and the right side is 1, so c has to be 1/2, since a is 1/2. So this whole thing simplifies to 1/2. 1 over u plus 1 plus, I'm gonna split the terms, so bu, which is minus 1, yeah, so this should be minus u over 1 plus u squared, plus yeah, this is squared, plus 1 over 1 plus u squared du. And then now we can do, I guess we have 1/2. This is just a ln of u plus 1, and then minus 1/2 ln of 1 plus u squared, and then plus, this is arc tan of u, tan of u, and then we're evaluating this from 0 to infinity. So I'm assuming this, we're doing the limit, so I just don't want to write limit as this. We could have done this, like we could have done, I don't think this really is a proper term, so we could have just wrote a over here and then done the infinity thing. But that's what I'm assuming in this scratch work. I just don't want to go through all that. So I guess ln, yeah, and then there's the 1/2, so everything is there. So this, we can combine them. We get like infinity minus infinity, and that doesn't really make sense. To make sense out of that, I guess what we'd do is we can combine these two, so we get ln of u plus 1 over 1 plus u squared, square root of this plus arc tan of u from 0 to infinity, and then we and then we have the 1/2 here, and then if we plug in 0, the arctan would go to 0, and then this is just 1/1, which ln of 1 is 0, so the lower limit gives us 1. And the upper limit, this is just going to be 1 as u goes to infinity, and then this is going to be pi over 2, I believe. Yeah, okay. So then pi over 2 times 1/2, that's pi over 4. So that's our answer. And then I guess, this is not really formal, but I skipped a lot of steps. But this I guess the condensed and neat solution, I guess. So we have this, that's the question, and then I guess we skipped a lot of steps, but this simplifies to this part over here, and then we're doing u substitution, and then this simplifies, and we get pi over 4. Yeah, that's it.